A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
Alright, we are back, and honestly, I have been looking forward to this one all morning. Herman, you know that feeling when you finally get a new tool. You are excited to really push it to its limits. You have paid the premium subscription, and then, click. The screen tells you to come back in 2 hours. It is the ultimate buzzkill. You are in the zone. The code is flowing. The agent is actually understanding the architecture, and then the gate drops.
Oh, the dreaded 429 error. Too many requests. It is the digital equivalent of a door slamming in your face right as you are getting into a rhythm. Herman Poppleberry here, by the way, and yes, this is a pain point that is becoming the central conversation in the developer community right now. We are seeing this massive irony where the more you pay, the more you realize how limited you actually are.
It really is. Our housemate Daniel sent us a prompt today that hits on exactly this. He was looking at the rollout of Claude Code, which is Anthropic's new agentic tool, and he noticed that even people on the highest tiers, we are talking $200 a month for the comprehensive plan, they are hitting these rate limit ceilings almost immediately. It is not just a minor inconvenience, it is a fundamental wall.
It is a fascinating paradox, corn. You pay more to get more, but the way these agents work, they consume resources at a rate that the current consumer software as a service model just was not built to handle. Daniel's question is really about the future of reliability. If a business depends on these agents to run 24/7, how do they move past these arbitrary limits? Do they just pay massive API fees, or is there a fundamental architectural shift required? We are talking about the difference between a toy and a utility.
That is the core of it. We are moving from AI as a chatbot, where you ask a question and wait for an answer, to AI as a business dependency. And if it is a dependency, it cannot have a maybe attached to its availability. You do not want your automated security guard taking a nap because he talked too much in the first hour of his shift. So let's dig into this Agentic Throughput Gap. Herman, explain why an agent like Claude Code hits a wall so much faster than you or I would if we were just chatting with the model.
It comes down to the difference between human speed and machine speed. When you use a standard chatbot, you type a prompt, you read the response, you think for a minute, and then you type again. That human in the loop creates a natural buffer. The model has plenty of time to breathe between your requests. But an agentic loop, that is a different beast entirely. An agent like Claude Code is designed to take a high-level goal, like fix this bug in the repository, and then it starts a recursive loop. It reads a file, analyzes the code, realizes it needs to check another file, runs a test, sees the test failed, and then tries to fix the code.
Right, and each of those steps is a separate call to the model. It is not one long thought, it is a series of rapid-fire decisions.
And it happens in seconds. What would take a human 20 minutes of clicking and typing, the agent does in 30 seconds through 10 or 15 back-to-back API calls. This is what I call the Agentic Throughput Gap. The rate limits on these $200 plans are usually calibrated for high-volume human users. They are not calibrated for autonomous agents that can fire off 100 requests while you are getting a cup of coffee. The providers are essentially trying to protect their compute clusters from being overwhelmed by millions of agents all running recursive loops at the same time.
And there is a hidden cost here too, right? It is not just the number of requests, but the amount of data being sent back and forth. I was reading about the context window tax the other day. Can you break that down for us? Because I think people underestimate how much weight each request carries.
That is a huge part of why people are hitting these limits so fast. In a standard conversation, the history builds up slowly. But an agent often has to send the entire state of the project, or at least a large chunk of it, with every single turn of the loop to maintain its reasoning chain. If the agent is working on a complex task, it might be sending 50,000 tokens of context with every single request. If it does that 10 times a minute, you are burning through 500,000 tokens in 60 seconds. Most consumer tier rate limits for tokens per minute are nowhere near high enough to sustain that for more than a few minutes of continuous work. We talked about this back in episode 795 when we discussed sub-agent delegation. When one agent hires another agent to do a subtask, the token usage does not just double. It often grows exponentially because both agents need to share that massive context window to stay aligned.
It is almost like trying to run a factory off a residential power grid. You can plug in a few tools, but the moment you start the assembly line, you blow the fuse. And the fuse here is the rate limit. So, if the fuse is the problem on these software as a service plans, what does the industrial grade power grid look like? How does a serious operation ensure that their agent does not just stop mid-sentence?
Well, the first step is moving away from the chat interface entirely. Tools like Claude Code are great for individuals, but for a business that needs certainty, you have to move to the API level. But even then, standard pay-as-you-go. API tiers have rate limits. They are higher, sure, but they are still there to prevent one user from monopolizing the entire cluster of GPUs at Anthropic or OpenAI. Even if you have the money, you might not have the tier status to get the throughput you need.
So even if you are willing to pay the per token fee, you might still get throttled if your agent gets too ambitious with its loops. That seems like a massive bottleneck for innovation.
Precisely. This brings us to the first major solution for 100% certainty, provisioned throughput. If you look at enterprise providers like Amazon Bedrock or Azure OpenAI, they offer something called provisioned throughput units, or PTUs. Instead of paying per token, you are essentially renting a dedicated slice of the hardware. You are paying for a guaranteed amount of compute capacity that is yours and yours alone. It is like having a private lane on the highway that no one else can use.
That sounds expensive. I am guessing we are not talking about $200 a month anymore.
It is very expensive. We are talking thousands, sometimes tens of thousands of dollars a month, depending on the model and the capacity you need. But for a global enterprise that has an AI agent handling their entire customer support flow or their DevOps pipeline, that cost is justified by the certainty. With a PTU, there is no 429 error because you are not competing with anyone else for those specific GPUs. You have bought the silicon time. But Daniel's prompt mentioned users who might not have that massive enterprise budget or the technical team to manage a massive on-premises cluster.
If you are a mid-sized operation or a very serious solo developer and you need that always-on reliability without the $10,000 a month price tag, where do you go? Is there a middle ground between the toy subscription and the skyscraper enterprise plan?
This is where the architectural shift gets interesting. If you cannot afford to rent a dedicated slice of a closed model like Claude 3.5 Sonnet or GPT-4o, you have to look at the open weights world. We talked about this a bit in episode 938 when we discussed the AI agent operating system. The standard solution for always-on certainty at a lower price point is to move your agentic workflows to models like Llama 3.3 or Qwen 2.5.
But wait, are those models actually good enough to handle the complex reasoning that something like Claude Code does? I mean, Claude is the gold standard for coding right now. Can Llama really keep up when the tasks get hairy?
A year ago, I would have said no. But today, in March of 26, Llama 3.370 billion is incredibly capable for most agentic tasks. And here is the kicker, you can take that model and deploy it on a managed GPU cloud like RunPod or Lambda Labs. Instead of paying a subscription to a chat service, you are paying for the hourly rental of an A100 or an H100 GPU. You are essentially building your own private API.
Okay, so walk me through that. If I am running my agent on a dedicated GPU I have rented on RunPod, what happens to my rate limits? Do I still have to worry about how many tokens I am pushing through the system?
They disappear. Because you own the compute for the duration of the rental, you can hammer that model with as many requests as the hardware can physically process. If your agent wants to run 1,000 loops an hour, it can. The only rate limit is the physical speed of the GPU. This is the only way to get true deterministic certainty. You are not at the mercy of a service provider's load balancer or their fair use policy. If the GPU is sitting there, it is yours to use at 100% capacity.
That seems like the logical conclusion for any production-grade agent. But I imagine there is a trade-off in terms of maintenance. It sounds like a lot of work to set up and keep running.
Huge trade-off. This is the classic build versus buy tension we see in every part of the tech world. If you use Claude Code or a software as a service tool, you get the best model in the world with zero setup, but you get the rate limits. If you self-host an open weights model on a rented GPU, you get infinite throughput and certainty. But now you have to manage the inference server, you have to handle the scaling, and you have to make sure the model is actually performing the task correctly. You become a systems administrator as much as a developer.
It is also worth noting that the always-on nature of a rented GPU means you are paying for it even when the agent is idle. If your agent only works for 6 hours a day, but you keep the GPU running for 24, you are wasting a lot of money. The meter is always running.
Which is why the standard solution for businesses is starting to look like a hybrid architecture. You use the high-end, rate-limited software as a service models for the brain work, the high-level planning where you need the absolute best reasoning. But then you offload the grunt work, the repetitive loops, the file reading, the basic code formatting, to a dedicated, always-on open source model. This preserves your premium rate limits for the stuff that actually requires a high IQ.
That makes a lot of sense. It's like having a senior architect who is very busy and expensive, and a junior developer who is always available and sits in the office 24/7. You do not ask the architect to format your CSS files or write boilerplate unit tests. You save their rate-limited time for the hard architectural decisions.
Right. And this actually solves the context window tax we mentioned earlier. If you have a junior model running on a dedicated GPU, it can handle all the context-heavy searching and summarizing. It then passes a much smaller distilled prompt to the senior model like Claude. This preserves your rate limits on the premium model while ensuring the agent never actually stops working. You are essentially using the open source model as a preprocessor or a context filter.
I want to go back to something Daniel mentioned in the prompt about the unacceptable uncertainty. He is right. If you're building a system where an AI agent is supposed to monitor a server and fix issues as they arise, you cannot have a situation where the agent says, "I know how to fix this, but I've used up my credits for the hour." That is a catastrophic failure in a business context. Imagine a self-driving car telling you it has reached its request limit while you are on the highway.
It really is. And I think this is a wake-up call for the AI industry. We have been in this honeymoon phase of chatbots where we are just happy the thing can talk to us. But as we transition to agentic AI, which we explored back in episode 795 regarding sub-agent delegation, the requirements change. Reliability becomes more important than raw intelligence in many cases. A model that is 80% smart but 100% available is often more valuable than a model that is 95% smart but only available 50% of the time. In production, uptime is the only metric that matters at the end of the day.
That is a very conservative, pragmatic way of looking at it, and I think it is the right one. You want the dependable workhorse. You want the donkey that keeps pulling the cart even when the path gets steep, not the racehorse that decides it is too tired to run today.
And speaking of donkeys, the infrastructure side of this is where the real innovation is happening. Companies like Grok or Together AI are building these massive high-speed inference engines specifically for this purpose. They are moving away from the chat model and toward inference as a utility. They want to be the water company or the electric company for AI. You turn the tap and the tokens come out. No limits, you just pay for what you use.
But even with those providers, you are still at the mercy of their infrastructure, right? If their servers go down, your agent goes down. You are still renting someone else's computer.
True, but their service level agreements, or SLAs, are much more robust than a $20 a month ChatGPT or Claude Pro subscription. When you move into the API and infrastructure world, you are signing contracts that guarantee a certain level of uptime. This is the shift Daniel is sensing. We are moving from consumer toys to enterprise infrastructure. It is the professionalization of the entire stack.
So, if I am a listener hitting that $200 wall right now, what is my immediate move? If I do not want to spin up a whole GPU cluster tomorrow, what is the bridge to that always-on certainty?
The first move is a token velocity audit. You need to actually look at your logs and see how many tokens your agent is consuming per minute during its peak loops. Most people are shocked by the number. They think they are using a few thousand, but it is often in the hundreds of thousands. Once you have that number, you look for a provider that offers usage-based tiering rather than subscription tiering.
Explain the difference for those of us who are not looking at API consoles all day.
A subscription tier like Claude Pro gives you a bucket of usage for a flat fee. When the bucket is empty, you are done. A usage-based API tier, like what you get directly from Anthropic's Developer Console or Google Vertex AI, does not have a bucket. It has a flow rate. As long as you stay under a certain number of tokens per minute, you can keep going forever. And as you spend more money, they automatically increase your flow rate. You are paying for the volume of the stream, not the size of the tank.
So it's not about running out of credits. It's just about how fast you can go at any given moment.
For most users, moving from the Claude Code app to using the Claude API inside a tool like Continue or Aider, or even a custom script, solves the running out of credits problem immediately. You might still hit a rate limit if you go too fast, but you will never be told you are done for the month. You just have to wait 60 seconds for the rate limit window to reset. It is a much more manageable kind of friction.
But that still introduces that uncertainty Daniel was worried about. That 60-second pause could be the difference between catching a bug and letting it hit production. If an agent is in the middle of a critical deployment, a 60-second wait is an eternity.
Which brings us back to the ultimate solution, the always, on GPU. If you want zero uncertainty, you have to control the hardware, whether that is a rented H100 in the cloud or a Mac Studio with M3 Ultra sitting on your desk in Jerusalem. If the silicon is under your control, the rate limit is a physical constant, not a business decision made by a CEO in San Francisco. You are limited only by the laws of physics and the speed of light.
I think there is a broader point here about the democratization of AI. We are told that these models are for everyone, but the rate limit ceiling creates a new kind of class system in tech. There are the people who use AI as a toy and are fine with limits, and then there are the people who use AI as a tool for production, who have to build their own infrastructure to bypass those limits. It feels like we are seeing the emergence of a new, compute-rich class.
It is the same as any other industry. Corn. Anyone can buy a hammer at the hardware store. But if you are building a skyscraper, you do not go to the hardware store. You contract with a steel mill and a crane operator. We are seeing the industrialization of AI. The weird prompts we used to play with are now becoming the critical inputs for business logic. And businesses require stability. They require the ability to forecast costs and performance with 100% accuracy.
And that is why I love these conversations. We are watching the transition from the magic trick phase of AI to the boring infrastructure phase. And as we always say, the boring stuff is where the real money and the real impact are. When the tech becomes invisible and just works, that is when it actually changes the world.
If you can make your agent boring and reliable, you have won. You want your AI to be as dependable as the dial tone on a telephone used to be. You pick it up, and it is just there.
So let's talk practical takeaways for the people who are feeling that frustration. If you are hitting the wall, the first thing you do is stop using the web interface or the Pro app for heavy agentic work. You are using a screwdriver when you need a power drill.
Right? Move to the API. Yes, it might cost more if you are a heavy user, but the ceiling is much, much higher. Second, look into model distillation or routing. There are tools now that will automatically send easy tasks to a cheap, fast, unlimited model and save the hard tasks for the premium model. This is the hybrid architecture we talked about. It is about being smart with your resources.
And third, if you are really serious, if your business depends on it, start getting comfortable with open weights models. Download Ollama, rent a GPU on RunPod for a few hours, and see if Llama 3 can handle your workflow. You might be surprised. It is like realizing you do not need a Ferrari to deliver pizza. A reliable truck will actually get more work done because you are not afraid to drive it in the rain.
That is a great analogy. The Ferrari models like Claude 3.5 Sonnet are amazing, but they are temperamental in terms of availability and cost. The truck, models like Llama, are yours to drive as hard as you want. You can put 1,000,000 miles on them and they just keep going.
I think we should also mention the geopolitical angle here, just briefly. We are talking about certainty and always-on service. In a world where compute is the new oil, being reliant on a single provider's software-as-a-service platform is a huge strategic risk. If you are a company in a region that suddenly faces new export controls or policy changes, your agentic workforce could be turned off overnight.
That is a very real concern. It is why we see so much interest in sovereign AI lately. If you do not own the weights and you do not own the hardware, you do not own your business process. For a conservative-minded business owner, that kind of dependency on a centralized, often politically aligned Silicon Valley giant is, well, it's a vulnerability. It is a single point of failure that could take down your entire operation.
It's the ultimate deplatforming risk. If they do not like what your agent is doing, or if they just change their terms of service, your employees disappear. Building on open source infrastructure isn't just about bypassing rate limits, it's about digital sovereignty. It is about making sure that your business can survive regardless of what happens in a boardroom thousands of miles away.
You hit the nail on the head. It is about taking control of your own destiny in the age of automation. We are moving toward a world where every serious company will have its own private model garden running on its own dedicated hardware.
Well, this has been a deep dive. I feel like we have moved from a simple complaint about a $200 subscription to a fundamental discussion about the future of work and infrastructure. It is amazing how a single error message can reveal the entire architecture of the future.
That is the magic of these prompts. They seem small, but they pull on a thread that unravels the whole tapestry of how the world is changing. Daniel's frustration is the same frustration that will lead to the next generation of decentralized AI infrastructure.
Before we wrap up, I want to remind everyone that we've covered a lot of the technical building blocks for this in past episodes. If you are curious about how to actually set up that agentic operating system, go back and listen to episode 938. It goes into the nitty-gritty of how to orchestrate these models.
And if you want to understand the sub-agent delegation strategy that helps manage these costs and token limits, episode 795 is a great resource. It is all about how to break down big problems into small, token-efficient pieces.
And hey, if you are finding these deep dives helpful, do us a favor and leave a review on your podcast app or on Spotify. We are over 1,000 episodes in, and it is the reviews from you all that keep us reaching new people who are trying to make sense of this weird, fast-moving world. We read every single one of them.
It really does help. You can find all our past episodes, the full archive, and a way to get in touch with us at our website, myweirdprompts.com. We have an RSS feed there too if you want to make sure you never miss an episode.
Thanks to Daniel for sending this one in. It definitely sparked a lot of thoughts for us here in Jerusalem. It is a reminder that even in a city with thousands of years of history, we are all dealing with the same cutting-edge problems.
It's a good reminder that even the most advanced tech in the world still has to deal with the basics of supply, demand, and reliability. The laws of economics are just as stubborn as the laws of physics.
Indeed. Well, this has been My Weird Prompts. I am Corn Poppleberry.
And I am Herman Poppleberry.
We will see you all in the next one.
Stay curious and keep those agents running.
Talk to you soon.
Goodbye.
So, Herman, I was thinking, if we are donkeys and sloths, does that mean our rate limits are naturally lower because we move slower?
Actually, Corn, a sloth's rate limit is very high. It just takes you 3 days to finish one request. You have high throughput but terrible latency.
Fair point. I will get back to you on that in 72 hours.
I will be waiting.
All right, for real this time. Thanks for listening, everyone.
Take care.
See ya.
Bye.
Seriously? We are done now.
Stop talking, Corn.
Okay. Going to sleep.
Good.
But what if the sloth had a GPU?
Corn.
Sorry. Bye.
Goodbye.
MyWeirdPrompts.com. Check it out.
We are leaving now.
Right. Jerusalem out.
This episode was generated using Gemini Flash 3. Text-to-speech engine was Chatterbox.
Thanks for listening to our show, My Weird Prompts, where our thoughts go from slow takes to facts on cue. We change and